All right, so in this lab, we're going to look at the enthalpy of solution, and specifically, we're going to look at ammonia nitrate. Ammonia nitrate is found in the instant cold packs. And so the idea is that when ammonia nitrate is introduced to water, the ammonia nitrate will absorb the heat from the water. The dissolving of that salt is called dissolution, and the heat that's associated with the dissolving process is the enthalpy of solution. Now, this is an endothermic process, and what that means is that the ammonia nitrate is going to absorb heat from the surroundings. And so what we would expect to see is that when we put ammonia nitrate in water, we are going to see a temperature drop. So we are gonna observe this and record our data. We're going to start the virtual chemistry lab right here. We're going to select thermodynamics and then select the enthalpy of solution from the list of assignments. So we come to thermodynamics, we select the enthalpy of solution, and calorimetry is loading. Now there's a few things to notice when you do this. This is your calorimeter. This is a coffee cup calorimeter. There is a stir here. You should be able to see that the stir is spinning around. Every time I've logged in to do this, which has been quite a bit, the stir has been spinning around. You also see a thermometer here, and that's recording the temperature. And the thermometer is blown up here so we can see the temperature here. Here's our ammonia nitrate, and they've already got a mass that's weighed out for us. And so if you look at, let me get rid of that. If you look at the instructions, it says a weigh paper will be on the balance with approximately 2 grams. Now, it's not going to be exactly 2 grams. Every time I log in, it's a different amount. So make sure that you record your amount, not the data that we're seeing on the screen here. So you need to walk through and do the lab. You need to record the mass of the sample in the data table. So the data table is right here. That's where you're going to record your mass. If you can't see it, you can zoom in. So if you come over here, you can zoom in and you can look at it more closely. It's 2.0590 or 89. Remember, there's going to be some fluctuation, grams. Now, the coffee cup calorimeter is on the lab bench. It's filled with 100 milliliters of water. And something important to remember is because the density of water is 1 gram per milliliter, if you have 100 milliliters of water, that's also 100 grams of water. Now we're going to do something that's a little out of order. Don't click on the lab book to open it. The lab book will work without clicking on it to open it. And if you open the lab book, it takes up a lot of space. So just leave the lab book closed. We've made sure the stir's on. Now, in the thermometer window, we're going to click Save to begin the recording. Okay, and we're going to allow 20 to 30 seconds to obtain a baseline temperature of the water. And this is just to account for any strange fluctuations that you could see. Now, once we've taken our 20 or 30 seconds, we're going to drag the weigh paper with the sample to the calorimeter, and it's going to snap in place. And it always takes me a little while for this to work. So don't be frustrated, it just takes a while. You're going to pour it into the calorimeter. Now you don't have to take the lid off, it's going to do that automatically. It says observe the change in temperature until it reaches a maximum, and in our case it's actually going to reach a minimum because the temperature is going to drop. And then record the data for an additional 20 to 30 seconds and click stop. Now we can accelerate this so you don't have to wait the full 5 minutes, and so we'll be able to do that. So we take this mass, we come over here, and there it went. It's going to snap into place. Okay, we're going to add it, and then we're going to observe what happens. So and this is the accelerate button, but what you're seeing is a drop in temperature. While this temperature is dropping, that dissolution process, the ammonia nitrate, as it dissolves, is absorbing heat from the water. Okay, and so let's zoom that along. There's our accelerate button. And what we're looking for is for this to level off. All right, so that looks pretty level to me, okay? And so it says, once you're done, click stop. Okay, so that looks very, very level. I'm gonna come over here and I'm gonna click stop, and I'm gonna open up my lab book. Now, when I open up my lab book, you're gonna have calorimetry data here. You click on the calorimetry data. You need to record your initial temperature, right, which is 25.01 in this case. And every time I've done it, it's been a little different. but 25.01. And then you need to record your lowest temperature, which looks like it might be 23.54 is what I think we're saying. Okay, so that's our lowest temperature. You need to copy this data, so you're just going to hit the copy button, and then you need to paste it into a Word document, and you're going to upload your data with your laboratory report so that I can check all your calculations. All right, and so that's the virtual lab. And so we've got our initial temperature and our final temperature. We're going to calculate delta T, and the way we do this is we take our initial temperature and subtract our final temperature. Now, when you do this, you'll get a positive number, right? Because, for example, our initial temperature here was 25.01, and we'll subtract 23.54, and so we'll get a positive number here. So what that tells us is that the addition of NH4NO3 to the water is endothermic. It's a positive number. The NH4NO3 is gaining heat, right? And so because it's gaining, we give it a positive number. So it's an endothermic process, and the sign of the change in enthalpy should be positive. Now you're going to determine the number of moles of NH4NO3 in the sample by using the molecular weight. And then we're going to calculate the amount of heat that's absorbed or lost by the water. And we're going to do this using this equation here. Q is heat, M is mass, C of the water is the specific heat of the water, the heat capacity of the water, and it's given to you right here, times the change in temperature that you calculated right here. So it says assume the density of the water is 1 gram per milliliter. So you had 100 grams of water, and the mass that you're going to use is the water and the substitute for M. And what they're talking about here is just the amount of NH4NO3. So the water that you added and the amount of NH4NO3. Delta T is the change in temperature of the water, and the specific heat capacity for the water is 4.184 joules per gram times Kelvin. What's the heat absorbed or lost in joules of the water? So what you're going to do is you're going to take your mass of your water plus your mass of your NH4NO3. You're going to multiply it by 4.184, and then you're going to multiply it by your change in temperature. And this will give you a unit of joules, which is a unit of energy. And so this should be kind of a biggish number. When I did this, I got right around 500 or 600, so that's what you should be getting. And then it says the heat transferred to or from, so our heat is being transferred to NH4NO3, can be divided by the moles of NH4NO3 to obtain the molar heat of the solution. So take the heat that you calculated here and divide it by the moles. Now this is going to give you a really big number because it's in joules, okay? They're asking for it in kilojoules. So not only are you going to take your heat and divide it by the number of moles, but you also need to convert it from joules to kilojoules. And so your answer here should be right around 25.69. It will not be exactly 25.69. So when I did this, I got 24.08 kilojoules. Okay, so it'll be close, but it won't be exact. And then you're going to figure out your percent error. So to do this, you're going to use your answer, and then this is the accepted value. So you'll put the accepted answer here and the accepted answer here and multiply by 100. And this will give us the percent error. So that is how we calculate the amount of heat that is absorbed by the NH4NO3. And it looks like there's a typo here. It says the accepted value for the heat of solution for sugar. We're not looking at sugar, we're looking at NH4NO3. So that's a typo there. But that's it. That's all we're going to do with the lab. Again, a few reminders. You need to show all your work, right? You just can't write down the answer. So you have to show your mathematical reasoning. You need to show all your steps. You need to upload this lab report and your data that's copied from here where you've pasted it into a Word document. So I'm looking for 2 documents to be uploaded.